as we've discussed, the argument, or the theta angle, is the smallest angle from the positive real axis to the vector of the modulus. And in the fourth quadrant, the argument is going to be negative since we are moving clockwise. When we moved counterclockwise in quadrants 1 and 2, the arguments were positive. So since we're moving in the opposite direction, the argument will be negative. So let's say we were asked to find the argument of 3 minus 4i. Step 1, we would go to 3 on the real axis. Step 2, we draw a dotted line down to negative 4 on the imaginary axis. And we plot the point here as the third step. And then draw a line from the point to the origin for step 4, creating our right triangle. Now, one thing to note, in the fourth quadrant, when we draw our right triangle, the angle closest to the origin in the triangle is the same angle that is the smallest angle from the positive real axis to the vector of the modulus. So in the fourth quadrant, this is theta, not alpha. In the third quadrant, when we drew our right triangle, the angle closest to the origin inside of that triangle was not our argument or theta, but in the fourth quadrant it is. So we will not need to calculate an alpha angle in the fourth quadrant. So we have our right triangle, and the side opposite is equal to 4, the length of the imaginary number. The side adjacent is 3, the real number. Now, one thing to keep in mind though is once we find the inverse tangent of this angle, that will give us a positive angle. We'll still need to multiply that angle by negative 1, since our argument in this quadrant will always be negative. So we'll find the inverse tangent of the opposite side over the adjacent, which is 4 over 3, giving us negative theta is equal to the inverse tangent of 4 over 3. When you plug that into your calculator, we get that negative theta is equal to 53 degrees. So to get theta, we want to multiply both sides by negative 1, giving us theta is equal to 53 degrees times negative 1, which means theta, or our argument, is equal to negative 53 degrees. And to get this answer into radian form, we want to multiply negative 53 degrees by pi over 180 degrees. When we do so, negative 53 degrees divided by 180 degrees gives us negative 0.29 radian. So the answer would be negative 53 degrees, or negative 0.29 radian. Let's have you try a few practice questions. Question number 1. Find the argument of 7 minus 7i. Question number 2. Find the argument of 5 minus 3i. Question number 3. Find the argument of 2 minus 9i. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we want to find the argument of 7 minus 7i. Step 1, go to 7 on the real axis. Step 2, draw a dotted line down to negative 7 on the imaginary axis. And the third step, plot the point. We then want to draw a line from the point to the origin so that we can create our right triangle in the quadrant. And this angle closest to the origin is our theta, or our argument that we're looking to calculate. With our right triangle, we see the side opposite is 7 and the side adjacent is 7. So we'll find the inverse tangent of 7 over 7 to get our negative theta. The inverse tangent of 7 over 7 is equal to 45 degrees. And since we know in quadrant 4 our theta must be negative, we'll multiply negative theta by negative 1 to get theta. So the argument is equal to 45 degrees times negative 1, which means the argument is equal to negative 45 degrees. And to get this answer in radian form, you'll want to multiply negative 45 degrees by pi over 180 degrees. Negative 45 degrees divided by 180 degrees shows us that the argument is equal to negative 0.25 radian. So the answer to question number 1 is negative 45 degrees and negative 0.25 radian. Question number 2, find the argument of 5 minus 3i. So step 1, go to 5 on the real axis. Step 2, draw a dotted line down to negative 3 on the imaginary axis. In step 3, plot the point. Step 4, draw a line from the point to the origin, creating a right triangle. The angle closest to the origin here, this is going to be our argument. And the side opposite of theta is 3. The side adjacent is 5. So when we find the inverse tangent of the opposite over adjacent, it's 3 over 5. Giving us negative theta is equal to the inverse tangent of 3 over 5. When you plug that in, you get negative theta is equal to 31 degrees. So to get theta, we want to multiply both sides by negative 1, giving us positive theta is equal to 31 degrees times negative 1, which shows us that the argument, or theta, is equal to negative 31 degrees. And to get this answer into radian form, you want to multiply negative 31 degrees by pi over 180 degrees. When we do so, negative 31 degrees divided by 180 degrees gives us negative 0.17 radian. So the answer to question number 2 would be negative 31 degrees and negative 0.17 radian. Question number 3. We're asked to find the argument of 2 minus 9i. Step 1, go to 2 on the real axis. Step 2, draw a dotted line down to negative 9 on the imaginary axis, and then plot the point. You then want to draw a line from the point to the origin, creating a right triangle. The angle closest to the origin here is going to be the argument we are looking for. And we see with our triangle, the side opposite of the angle is 9, the side adjacent is 2. So when we find the inverse tangent, it'll be 9 over 2. That gives us negative theta is equal to the inverse tangent of 9 over 2. And once you plug that into your calculator, you get negative theta is equal to 77 degrees. So to get theta, we want to multiply both sides by negative 1. Giving us theta is equal to 77 degrees times negative 1, which shows us that theta, or the argument, is equal to negative 77 degrees. And to convert this answer into radian form, you want to multiply negative 77 degrees by pi over 180 degrees. Negative 77 degrees divided by 180 degrees gives us theta is equal to negative 0.43 radian. So the answer to question number 3 is negative 77 degrees and negative 0.43 radian.